In this lesson, we're going to explore 4 problems that involve not only chain rule, but either product rule and quotient rule at the same time. So let's go ahead and dive into our very first problem. And here it is, y equals te to the negative t squared. Now the first thing I want us to recognize is that we really have 2 functions of t going on here. We have t and we have e to the negative t squared, which means on the outside we need to be doing product rule. So let's go ahead and start with product rule.
So here's our 2 parts, t and e to the negative t squared. So first we leave t alone, and then we want the derivative of e to the negative t squared, which is a little more complex than some of our other derivatives. So I'm just going to take a note to do it later. So d dt of e to the negative t squared plus, and now we'll take the derivative of t, which is just 1, and leave e to the negative t squared alone. All right, now let's explore right here, what is the derivative of negative e to the negative t squared? So we got to think about what is our inside function and our outside function. So our inside function, sometimes we use the letter u for it, is negative t squared, which means our outside function is simply going to be e to the u. So with that in our heads, we're ready to take that derivative. So we have t, and then the derivative of this, which is e to the u, derivative of e to the u is e to the u, our u is negative t squared, times the derivative of the inside, and the derivative of negative t squared is negative 2t, plus e to the negative t squared. All right, so we've actually found our answer here, but certainly on a multiple choice test or in the back of the book, it would not be left like this. So if we look at this, we really have 2 terms going on here. This term plus that term. And so when we look at both of them, we see that they both have an e to the negative t squared. So I'm going to factor out an e to the negative t squared. And in the first term, I'm left with t and negative 2t, which multiplies to negative 2t squared. And in the second term, I have to say to myself, e to the negative t squared times what is going to give me e to the negative t squared? That's just going to be 1. And we've finished our first problem. All right, so let's take a look at this next problem. Clearly, we're dividing here, so we're going to be using quotient rule in this problem. So let's go ahead and get started with quotient rule. So f prime of x equals, all right, so low d high minus high d low. So let's start with that. Low, or the bottom function, is 2 to the x. D high, okay, that's a complex one again. So I'm just going to write a note to take its derivative in a minute, and we'll come back to it. So d dx of the square root of x squared plus 1 minus high, which is the square root of x squared plus 1, d low. So the derivative of the bottom is 2 to the x times natural log of 2. That whole thing is over 2 to the x squared. All right, so now let's take the derivative of this portion that we didn't take the derivative of yet. So we need to consider this, and we want to think about what is our inside function and what is our outside function. So clearly the inside is what's inside the square root, and we'll call that u. U equals the square root of x, no, not the square root, but just the inside. Let's fix that up. So u equals x squared plus 1. And then if that's the inside, then we are just left with the square root of u. So the outside is the square root of u, or u to the 1/2. All right, so I think we're ready to take that derivative. So here we go. We have the 2 to the x already there. Okay, the outside is u to the 1/2, so we're going to get 1/2 u to the negative 1/2. Of course, our u is just what's inside here, x squared plus 1, times the derivative of the inside. Our inside was x squared plus 1, so that's 2x. All right, minus the square root of x squared plus 1 times 2 to the x times the natural log of 2. And that whole thing is over, and we can take this 2 to the x, and we can multiply those exponents, so 2 to the 2x. All right, the only thing I'd probably clean up on this one is that this 2 here does cancel with that 2 there. Otherwise, there's not a lot we can do, although the back of the book might do this. So let me just show you what you might see in the back of the book. I mean, we've got the right answer so far, but what they might do is say, hey, we can factor out a 2 to the x, because you're going to notice right over here, we have a 2 to the x in the first term and also in the second term. So then I have a x squared plus 1 to the negative 1/2. I also have an x, I'll write it in the front, minus, I'll put the natural log 2, and then the square root of x squared plus 1. And I'm going to go back to the bottom. This is the reason we shouldn't square things out, is 2 to the x squared. And now that 2 to the x is a factor, I can cancel this out with one of those. And so there's also a good answer, cleaned up a little bit. All right, let's try another problem. So in this one, it looks like we've got another quotient rule. So let's go ahead and start off with our quotient rule. So we've got low, e to the 6, d high. So when I take the derivative of this, we're going to try this without writing our notes. So our inside function is 3x plus 7, which means my outside function is u to the 5th. So I'm going to have 5 u to the 4th. I know my u is 3x plus 7. And the derivative of the inside is 3 minus, so let's see, that was low d high minus high, 3x plus 7 to the 5th times the derivative of the bottom. So my inside function is 6x, my outside is e to the u, so I get e to the u is 6x, derivative of this inside is 6 all over e to the 6x. So we've done the problem. The only thing we might choose to do now is to factor out and simplify this. So correct answer here, to match with the back of the book or multiple choice, you may want to factor. And I want you to see that we have two terms, two pretty complex terms, but just two terms. So here we go. Out of the first term, I have an e to the 6x here, and I also have an e to the 6x here. They also both have a 3x plus 7, 4 of those. Here I have 5. And I can factor out a 3. So they have a lot in common. So we have a 3, an e to the 6x, and a 3x plus 7 to the 4th can come out of both of them. So then, oops, I forgot to square this up here. I'm going to go back up here and square this. Sorry about that. All right, so then, let's see, out of the first term, I took out the e to the 6x. I still have my 5. I took out the 3x plus 7 to the 4th, and I took out the 3. So all I'm left with is 5. In the second term, I still have one more 3x plus 7 because I only factored out 4 of these. I factored out the e to the 6x, and I factored out the 3, so I'm left with a 2. All over e to the 6x squared. Now you can see that this e to the 6x is going to cancel with one of those. And so now for a much cleaned up answer, we get 3x plus 7 to the 4th. And in here we can clean this up as well. So I just write a little note here, I get 5 minus 6x minus 14. So that's going to be a negative 6x minus 9 all over e to the 6x. There we go. We've got a cleaned up one. Some people might also take out a negative 3, so we could still go a little bit farther, but we've definitely got a cleaner version than we had up here. So again, this one up here is correct, but to match it up with the back of the book, you might have to do some algebra like this. All right, we've got one more example for you. And here's this one. And we can see that we've got a product rule problem again. So we've got this first function times the second. So here we go. Our first function, we'll just leave it alone. And we're going to take it times the derivative of the second. Our outside function is u to the 8th, so it's going to be 8x squared plus 7x to the 7th times the derivative of the inside, which is 2x plus 7 plus. Now I'm going to take the derivative of the first one. Outside function is u to the 3rd, so 3, 4x minus 1 squared times the derivative of the inside, which is 4, times the second one left alone. Now once we do this, we have a correct derivative. But once again, this can be cleaned up. If we take a look at this, again, we have just two terms. So we're going to look at what do they have in common. So as I look at this, let's see, I've got a 4x minus 1 to the 3rd here and a 4x minus 1 squared there, which means I can take out 2 of those because they both have at least to the power of 2. So you have an 8 here and a 3 and a 4 here. So clearly I can take a 4 out of both of them. Then my x squared plus 7x, I have 7 here and 8 here, so I can factor out 7 of them. And I think that's it. Okay, so here we go. Out of the first one, we're still left with a 4x minus 1 and a 2 and none of this and a 2x plus 7 plus. And out of this one, let's see, we still have a 3. These are all gone. The 4 is gone, but we have one of these, x squared plus 7x. So we've done our factoring. That definitely looks better. We can take it a few steps farther, so I'll just go and finish this up. X squared plus 7x to the 7th. And in here I'm going to FOIL. So let's see, that's 8x squared doubled is 16x squared. And then minus 2x doubled is minus 4x. Then outer plus 28x doubled is 56x. Minus 7 doubled is minus 14. Plus 3x squared plus 21x. And we're almost there. 4x minus 1 squared. X squared plus 7x to the 7th. And let's see, I have 19x squared. Oops. That was a parenthesis there. Let's see my x's. I have 52x, and that looks like 73x, I think, plus 73x. Yeah, because that's, yeah. And then lastly, just the one number, minus 14. All right, so there's our final answer. Now let's talk about on the homework. What do I care most about? I care most about that you're able to get that answer. On these problems, if you enjoy the challenge of matching it up, then I think you know, doing this extra work is good. If you've already spent a lot of time on your homework and you need to get to other things and you got this far, then that's good as well. One way to check it would be to enter your answer and the back of the book's answer in your calculator for like y1 and y2 and look at the table and make sure you have the same values. So that would be one way to check that you have the correct answer. All right, so with that, you have the information you need to do your next assignment.